We've spent a lot of time working with the equation. Make changes to the equation, how does that transform the graph? Now we should probably spend a little time working in reverse. If we have the graph, what was the original parent function? What changes were made to that parent function? And what is the equation of this new transformed graph? Just a few examples to look at. On the very first one, this classic V shape. Looks like the parent function must have been y equals absolute value of x. But normally that v starts here at the origin, has its vertex there. Here the vertex is here. Still appears to have a slope of 1. So what changes got made? Well, the vertex moved from 0, 0, left 3, and down 4. So those were the changes. How does that impact the equation? Well, y is going to equal some kind of absolute value, and the down 4 is minus 4 hanging off the end. The x's in here, remember x's do everything backwards. In order to come out to the same y value, they have to compensate. If you go left 3, the original in here must have been plus 3. Is that the right equation? Well, we should check. We should always check. Pick a point, put it in. So I'm going to check with the -3, -4. Y equals -4. The x equals -3. So -4 equals the absolute value of 0 minus 4. And -4 equals 0 minus 4 does check. Yes, this must be the equation of the transformed function. Number 2, with all the time we spent on polynomials, this should be a familiar shape. Y equals the cube of x. Normally, though, this positive cubic has its little twisty point right here at the origin. This one does not. It looks like it's been moved to the right 2 and up 1. So our equation, y is going to equal something cubed plus 1. X's got moved 2 to the right, which means in order to preserve the y value, what goes in here is going to have to be x subtract 2. Check it out. Can pick either one of these points. I'm going to use the easier one. When x is 1 and y is 0, so 0 for y, and 1 for the x. So 0 should equal -1 cubed plus 1, and the cube on -1 is -1. So that checks. And this would be the equation of the transformed function. Number 3 may look a little strange because it's not in its normal position, but that swoosh there, the original function was y equals square root of x. Once again, the parent function would have started here at the origin. That would have been its end point. But that's not where its starting point is now. Starting point got moved to the left 1 and down 2. So sorry about the handwriting here. The basic equation then would look like y equals square root of something, subtract 2. Because the x's have been moved to the left, then what was in the equation has to be x plus 1. And it didn't really need those parentheses in there, but it's okay. Check it out. So I'm going to try it with a 0, negative 1. Y is negative 1. X is 0. So does negative 1 equal the square root of 1 minus 2? Well, does negative 1 equal 1 minus 2? Yes, it does. And there's our equation. For the last one. Nothing fancy here. I'm sure for years you've been able to recognize this shape, but the parent function would have been y equals x squared. We can tell that it got flipped down, reflected across the x-axis. So the equation of the transformed thing is going to have to be negative something x squared, no pluses or minuses on the end, didn't get lifted up or down, didn't get slid left or right either. So we can check. I'm not going to check with 0, 0 because that can lead to false conclusions. I'm going to use the 1, negative 2 to check. So if we put a 1 in for x and square it, and then take its opposite, do we get negative 2? No, we don't. If we put a 1 in for x and square it, take its opposite, we get negative 1. Well, since this didn't get moved down any spaces or left, right any spaces, the only way to come up with this negative 2 instead of a negative 1 is if there was a multiplier of 2 in here. That this is a vertical stretch. So let's check this revised equation here. If we put a negative 2 in for y equals negative 2 times the square on x, does negative 2 equal negative 2 times 1? Yes, it does. So this does check out as being the equation of our transformed function. Would you please go now? There is one practice problem for you to try.